Okay, in today's lecture, we're going to start on something entirely different from what we've been doing um, this whole past week. We're going to start graphing linear equations that contain two variables. So, a couple of things I want to tell you before you actually start getting into the video here. First thing is, you are going to need some graph paper. You can find some graph paper on the My Math Lab by clicking on the button on the left-hand side that says graph paper. There you'll find a copy of one sheet that you can print out and make as many copies as you like. Okay, and the second thing I want to point out to you, these notes that I'm about to go over are already on the My Math Lab. Click on the notes section for test number 1, and you will see this handout filled out entirely as it is here. Okay, so let's start with graphing these linear equations that contain two variables, x and y. Well, first thing I want to tell you about this is that there's three different methods, and each method, I'll go over each method on the three videos that you'll look at for today's assignment. The first one is what we refer to as the point plotting method. Well, the point plotting method works by making this table of values here. Notice that I have three columns. I have a column for x, a column for y, and then a column for my points, my coordinates of my points um, that I'm going to find and actually plot on this line over here. One thing I want you to notice the labeling that I put on my coordinates of points. I call the coordinates of the first point A, the second one B, and then the third one C. That way, when they're on this line, you'll know exactly where these points are coming from. These points, this point right here, C, corresponds to this one. This point A right here corresponds to this point here, and this point B corresponds to this one over here. Okay, so let's see what it says about the point plotting method. This method requires a making of a table of values. It's the best way to do this, to use this method. In fact, you only want to use this method when the equation that you're trying to graph has one variable that it's already solved for. For example, look at the example that we're about to do. Do you see that this equation is already solved for x? So you want to use this method whenever the equation is already solved for either x or y. In this case, this one is solved for x. So this is how the method works. A very basic method. All we do is pick three values for either x or three values for y. So for either one of these. And notice what it says down up here. The underline denotes the chosen value. So I decided to pick three values for y instead of x. And why did I do that? Like it says down here, since this equation is already solved for x, pick three values for y. And we'll give the reason why we pick three values and not two. Okay. So I'm going to pick three values for y since this equation up here is already solved for x. Now look at the three values I pick. I can pick any three values I want, but there's certain ones that make the plotting of these points a lot easier. So why did I see? I could have just as well picked one for y, but if I put one in for y, then I'll end up with the following equation. If y were equal to one, I'd have x will equal 3/4 times 1 minus 2. Well, what's wrong with that? Well, if you take 1 times 3/4, then you'll see that you'll end up with a fraction minus a whole number. In other words, I have to do fraction work, and I really don't want to do that. So that's not a good choice for y. So what are good choices for y? Well, if you look at these three numbers that I chose, 0, 4, and -4, what they all have in common is that these three numbers are multiples of 4. Well, where's the 4 at? Well, if you look at the equation here, you'll see that there's a 4 in the denominator. That seemed to be the problem right here. That's why I had a fraction. So as long as I pick a number right here for y that is going to be a multiple of that denominator, it will cancel that 4 out. So that's why I chose 0, 4, and -4. So when you put 0 in for y, you put a 0 right in here, you get 3/4 times 0, which is 0, minus 2, so I get a -2 for the x. Let's do the next one. I'll do the next one over here. Now I'm going to put 4 in for y, and let's see what happens. You can almost do this in your head, but I'll put it here on paper. So when y is equal to 4, this is what's going to happen. X is going to equal 3/4 of 4 minus 2. Well, look at this. The 4's here just cancel out. That's the purpose of picking values for y that are multiples of that denominator. So that just leaves me a 3 minus 2. So x ends up having the value 1. That's the value that you see in the table right next to the 4. These two go together. Notice that I make an ordered pair, 1 comma 4, and then I label that point B. Okay, so you do the same thing. Take -4, plug it in for the y here, and then 4 divided by, well, -4 divided by 4 would be a -1. -1 times 3 would give me a -3 minus 2. That gives me a -5. That's where this one comes from. So then I put these together, and that forms this third point C right here. So the whole thing behind this method is making sure that you pick real good values for either x or y. And why did I choose values for y? Is because, like it says down here, this equation was already solved for x. If I would have picked the value for x, let's say, and put it in here, then what happens, I got to solve this equation for y. And I don't want to be solving equations since this one's already solved for x. So all I do is pick values for y, and it just works out the way it did right here. See how when I pick y to be 4, the 4's cancel out, and I get 3 minus 2, which gives me 1. There's nothing to solve since it's already solved for x. Now let's plot these 3 points. So I'm going to plot this point A. The x-coordinate is -2, the y-coordinate is 0. So that means starting at the origin, you go 2 units to the left, 1, 2, and then since y is 0, I stop right there. There's my point A. Now the next point has x-coordinate of 1, a y-coordinate of 4. So I start here, go 1 unit to the right, and then I'm going to go 4 units up. 1, 2, 3, 4. There's point B. Similarly, for point C, I start at the origin, and I go 5 units to the left. 1, 2, 3, 4, 5. And then I go 4 units down. 1, 2, 3, 4. And there's point C. Now, all I do is take my ruler. I put my ruler above these 3 points, and I draw a straight line through those 3 points. Now, why 3 points as opposed to 2? Well, it turns out that you can always draw a line through 2 points. They will always be collinear. But what if you plotted one of these points wrong? Let's say, for example, point A that has coordinates -2, 0. Let's say you would have plotted over here. Then you'll see that your line through points A and B would be different. So the third point right here, this point C, is like a check. If these 3 points end up being what are called collinear, that means they're lying on a straight line, and when I draw my line and it fits right through those 3 points, that means that I did graph my equation correctly. Okay, so that's the first method, the so-called point plotting method. It's a very good method. All you have to do is make sure that you pick three values for the variable that the equation is not solved for. Okay, be sure to look at the next video.